Welcome to today's tutorials. We'll be looking at past questions on IJMB from the year 2016. I would like you to get your writing materials ready with your calculators. We'll be back soon. Okay, we'll be working with section 1, section A, question 1. Given that sine 30 equals to half, obtain insert form tan 15 degrees. Now, we know that from our special angles, we have this as 2, √3, and 1. Now, this was generated from an equilateral triangle where all sides are 2. So if we divide this into 2, this becomes 1, 1. So bringing out this we have 2 and 1. So for us to find this becomes our √2 squared minus 1 squared equals to x. So x equals to 4 minus 1. Sorry, x squared. So x equals to 3. So x equals to √3. So that's how we came about this as x equals to √3. Now, having said that, we know that sine theta equals to opposite over hypotenuse, cos theta equals to adjacent over hypotenuse, and tan theta equals to opposite over adjacent. Now, since we are given that sine theta equals to half, which is opposite over hypotenuse, this will be our sine 30. So opposite will be 1 all over hypotenuse, which is 2. Our cos theta will be adjacent, which is √3 all over hypotenuse, which is 2. Okay, then our tan 30 in this case is supposedly going to be √1 over √3. But now we are not looking for √30, we are looking for tan. We are not looking for tan 30, we are looking for tan 15. In order to get tan 15, we have tan x over 2 equals to 1 minus cos x all over sine x, where x equals to 30 degrees. So this becomes tan 30 over 2 equals to 1 minus, what's our value for cos x? Cos 30 will give us √3 over 2 all over sine x, which is 30, will give us 1 over 2. So this becomes tan 15 equals to 1 minus √3 over 2 all over half. Now, if we turn this to multiplication, this becomes times 2 over 1. So these 2 will multiply all through. So we are having 1 minus √3 over 2. Okay, let me put it this way. 1 times 2 minus √3 over 2 times 2. Okay, 2 times 1 will give us 2. 2 we cancel 2, leaving us with minus √3. So in short form, tan 15 equals to 2 minus √3. Express √3 plus √2i all over √3 minus √2i in form of x plus iy. Now, for us to clear this short form, we'll multiply both the numerator and the denominator with the conjugate of our denominator. So that will give us root 3 plus root 2i all over root 3 minus root 2i times root 3 plus root 2i all over root 3 plus root 2i. Let's expand this bracket. We are having root 3 bracket root 3 plus root 2i plus 2 root 2i bracket root 3 plus root 2i all over root 3 bracket root 3 plus root 2i minus root 2i bracket root 3 minus plus root 2i. Now, root 3 times root 3 will give us 3. Root 3 times this will give us plus root 6i. This times this will give us plus root 6i. This times this will give us plus 2i squared. Root times root to cancel root, leaving us with 2 times 2, 4. So that will give us root 2i squared. All over this times this will give us 3. This times this will give us plus root 6i. This times this will give us minus root 6i. And this times this will give us minus 2i squared. Alright, from here, we are having 3 plus 2 root 6i plus 2i squared all over, for the denominator, we are having 3. This will cancel this, leaving us with minus 2i squared. Now, in vectors, we know that I squared equals to minus 1. So, imputing this for our I squared, we are having 3 plus 2 root 6i plus 2 bracket minus 1 all over 3 minus 2 bracket minus 1. So, this will give us 3 plus 2 root 6i minus 2 all over 3 plus 2. So here we will be having 3 plus 2, 3 minus 2 will give us 1. That will be 1 plus 2 root 6i all over 5. So putting it in this form will give us 1 over 5 plus 2 root 6i all over 5. So where our x equals to 1 over 5 and y equals to 2 root 6 over 5. Question 3. It says, obtain the quadratic equation whose roots are the reciprocal of the roots of the equation ax squared plus x plus c equals to 0. Now, this is our given equation. For our roots, we are having it as alpha and beta. Okay? Now, in solving for quadratic roots, we should always remember our formula that says x squared plus sum of roots plus x squared minus sum of roots plus product of roots. Okay, we should always remember this formula. Now, the says so looking for the reciprocal of the roots. will be 1 over alpha and 1 over beta. Now, for some of the reciprocals, we are having 1 over alpha plus 1 over beta, which is going to give us alpha beta as our LCM all over alpha, all over beta plus alpha, or alpha plus beta, whichever one. All right, for product of reciprocal, we are having alpha 1 over alpha times 1 over beta, which is going to give us 1 over alpha beta. Please, if you have any questions regarding this, put it down on the comment section and we are sure to reply. And please don't forget to subscribe. Now, coming back to this, we know that our alpha plus beta equals to minus b over a, and alpha beta equals to c over a. This is gotten from our original equations here. Now, for alpha beta from the original equation here, we are having this is b, which is 1. That will become minus 1 over c over a, and this will still maintain our c over a. Okay, now putting this into this and this, our alpha plus beta, which is going to become alpha plus beta all over alpha beta, will give us minus 1 over a divided by c over a, which in turn will become minus 1 over a times a over c. This will cancel out. So our alpha plus beta, alpha over alpha beta, will give us minus 1 over c. Now, for alpha beta, which is a product aspect, we are having 1 over alpha beta. So this will become 1 all over, our alpha beta is c over a, which in turn will become 1 over 1 times a over c. So our alpha beta, 1 over alpha beta is going to give us a over c. Now, imputing this, substituting this and this into our equation of x squared minus sum of roots, which is this, will become minus 1 over c x plus our product of roots, which is this, a over c. So this will become x squared minus times minus plus x over c plus ac. Now, since we're having a common denominator, we can simply cancel out by multiplying through the equation with c. So this becomes c x squared plus x plus a equals to 0. This will be our equation for the reverse reciprocal equation for that equation. Question 4. What is the remainder when the polynomial 3x cubed minus 2x squared plus 6x minus 1 is divided by x plus 1? Now, in solving this, we are going to have it this way. Let's use our long division method. We have x plus 1, and we have 3x cubed, minus 2x squared plus 6x minus 1. Now, let's go. X into this will give us 3x squared. 3x squared times this will give us 3x cubed. Now 3x times 1 will give us plus 3x squared. Now since the signs are the same, we are going to do what? We are going to subtract. So if we subtract, 3 minus 3 will give us 0. X squared minus x cubed minus s cubed will give us 0. So this will cancel out. Minus times plus is minus. So we are going to have a minus 2 minus 2 minus 3 will give us a minus 5x squared. So we bring this down, plus 6x minus 1. Now, let's divide with x again. X into this will give us a negative 5x. 5 times x will give us minus 5x squared. Minus times plus will give us a minus. 5 times 1 will give us a 5x. Okay, now we are having same sign, so we do what? We add. Now, minus 5x plus, we subtract. Minus times minus will make it plus, so it can cancel out. So minus 5x plus 5x will cancel out, leaving this with minus times minus plus. So we're having this and this will give us 11x minus 1. Okay, so now at those points, we are having x still here. So we bring x here, will give us plus 11. 11 times this will give us 11x plus 1 plus 11, which we are going to have as a positive. We subtract, will give us out. So this will give us a minus here, minus 1 minus 11 will give us a minus 12. So our remainder for this one is a minus 12. Show that sine theta equals to 2 tan theta over 2 all over 1 plus tan squared theta over 2. Now using our double angle formula that says that sine theta equals to 2 sine theta over 2 cos theta over 2. Okay, now let's express this in tan. This will become 2 sine theta over 2 cos theta over 2 divided by cos squared theta over 2 plus sine squared theta over. Now divide both numerator and denominator with cos squared theta over 2. So this becomes, for our numerator, let's separate it. Numerator. Now we are having 2 sine theta over 2 cos theta over 2 divided by cos squared theta over 2. Okay, now this can be shareable to both. So this becomes 2 sine theta over 2 cos theta over 2 all over cos theta over 2 cos theta over 2. Now this will cancel this, leaving us with sine theta over 2 all over cos theta over 2. But recall that tan theta equals to sine theta over cos theta. So replacing this with tan, this becomes 2 tan theta over 2. That's for our numerator. Now let's look at the denominator. For our denominator, we are having cos squared theta over 2 plus sine squared theta over 2 divided by cos squared theta over 2. Now, since this is addition sign, we can separate this cos squared for both sides. This becomes cos squared theta over 2 plus sine squared theta over 2 all over cos squared theta over 2 all over cos squared theta over 2. Now, this we cancel out to give us 1 plus, remembering our formula that says sine theta over cos theta is tan, equals to tan. So this becomes tan squared theta over 2. So now this is for our denominator. So now coming back to this equation, we have sine theta equals to, our numerator is 2 tan theta over 2, and our denominator is 1 plus tan squared theta over 2. So we've proven that sine theta equals to 2 tan theta over 2 all over 1 plus tan theta squared over 2. Alright, we just finished solving section A, and for comments, questions, put them in the comment section below and we'll get back to you. Please subscribe and click on your notification button so that when section B is up, you would receive the notifications for it. Thank you.